All right, y'all, we are up to level 6. This is what my students considered to be the hardest one-dimensional kinematics question that they ever had to do. So we're going to have a look at it now, and hopefully this will make some sense. It is a challenging question conceptually. The mathematics isn't a piece of cake either. So here we go. Little does the AP physics class know that though by day Mr. Bywater is a physics teacher, by night he is Bdubs, a superhero testing the laws of physics. One night, Bdubs is with Zaid at the top of a 330-meter tall skyscraper. Okay, lovely. 330 meters tall, down to the ground. All right, Bdubs is up there, and so is Zaid. You can tell this is Mr. Bdubs. This is Bdubs because he's got a cape. All right, so this is Bdubs. This is Zaid. All right, Zaid will drop a... Oh, he decides to test a common movie scene. Zaid will drop a 10-kilogram bowling ball off the building. It's safer than dropping a baby. The acceleration of an object free falling due to gravity is 9.8 meters per second squared. And 3 seconds after the ball is dropped, Bdubs will start down from the top of the building, trying to catch it before it hits the ground. So, you know the movie scene I'm talking about. Something's falling. It could be a lady. It could be a baby. It could be whatever. But something's falling, and the superhero says, "Oh, I better go save them," and dives down and catches them before they strike the ground. All right? So, now what makes this challenging is the fact that it says Zaid's going to drop the ball, and it's going to fall for 3 seconds before Bdubs starts down. Now, in addition, we know that the ball is going to free fall at 9.8 meters per second squared. So the acceleration is 9.8 meters per second squared, and it is down, so we may say, let's make that a negative 9.8 meters per second squared. It does say Bdubs here will fly at constant speed. All right, he's super fast. He doesn't have to speed up. He just, at the instant that he leaves the building, he is going at whatever speed Bdubs goes at. So the question is, what speed does he need to travel at in order to catch the ball 1 meter off the ground? All right, well, this sounds like I need to calculate a speed, so therefore probably going to need a table. Now, this is going to have to connect the ball and Bdubs, right? So I'm actually going to go ahead. I already know I need the ball and Bdubs together to figure out this information. So we'll go x naught, x, v naught, v, a, and t. They're both going to start at 330 meters at time 0. All right, now those both have two significant figures, but at time 0, they are both there. Now the ball is going to end up 1 meter off the ground, all right? That's what speed does he need to travel at in order to catch the ball 1 meter off the ground? So 1 meter off the ground, and in fact, we want Bdubs to be 1 meter off the ground as well. The initial velocity of the ball is going to be 0. And the initial velocity of Bdubs is going to be whatever his velocity B is. The final velocity of the ball, we don't know. Bdubs is going at a constant speed, so it's going to be VB. We've got the acceleration of the ball, which is negative 9.8 meters per second squared. All right. And we've got the acceleration of Bdubs, which is 0. Now, this is where it gets tricky. So first, the ball is just going to be time t, however long it takes. Time 0 was the point when we dropped the ball, and so it took that much time to get down to the bottom. Bdubs, however, is not going to be t, because if I put t there, then that means that he would need to be flying at this speed for the whole time that the ball was dropping, which is not true. Right? He waited for 3 seconds before he jumped. So in order for me to count this as his initial velocity, I need to start him 3 seconds later. So the time for Bdubs is actually going to be t minus 3. All right? So that t minus 3 means that whatever time the ball is falling for, Bdubs is going to move for 3 seconds less than that. The ball is already somewhere down here by the time that Bdubs starts trying to fly down and catch it. Okay, so this made it a little bit challenging. The other thing is there's a couple of variables, right? It may, you look at this and you say, well, I got some information about the ball. Can I calculate t? Well, maybe. Look at Bdubs. This is what I want. I want that velocity, but I don't have t and acceleration is 0. So when I'm looking at my equations, right, I'm thinking about that x equals x naught plus v naught t plus 1/2 at squared. I'm thinking, well, I've got x naught, I've got x, v naught, that's an unknown, that's what I'm looking for. Oh, this is an unknown as well, which means I actually have 2 unknowns there. Not cool. So I can't really solve it yet. But I do know the acceleration is 0, so if I could find one of those, then I can find the other one. All right, I've got the v equals v naught plus at. That becomes a problem because Bdubs acceleration is 0, which means I just get that, which I already know. And as we talked about in the other one, v squared equals v naught squared plus 2a x minus x naught. Again, I get, because the acceleration is 0, this term will go away, and I'll get this equals this, which, yep, I already know that. So it looks like I'm going to need to rely on this equation right here, which is that 1 is going to equal that 330 plus v naught, which is going to be whatever velocity he can fly at, times t, which is t minus 3. And then this, of course, is 0 there because the acceleration is 0. So I'm going to use this equation, but apparently I need time. So this is where the ball is going to come in important, because in order to solve this, I'm going to need to solve for time. And because this t is the same as that t, because I subtracted off 3 there, then I can solve for the time that the ball is going to be dropping. All right, so this part's pretty straightforward. I've got everything except for v, so let's go ahead and use that top equation again. So we'll go 1 equals 330 plus v naught t plus 1/2 a, which is negative 9.8, times t squared. All right, so I put in all the numbers about the ball there, and then I should be able to solve. So I'm going to take out my super duper fancy calculator here. I'm going to go 1 minus 330, so I'm going to subtract the 330 over, and then I'm going to divide by the 0.5. I'm going to divide by the negative 9.8, and I got an answer, and then I need to square root that 470 over 7. So 470, oh, no, sorry, I forget this calculator is more fancy than that. I can go divide by the answer, and I get 8.19. Now, I do get that t equals 8.19 seconds, but recognize that looking at significant figures, I only got down to 1 meter. That's 1 sig fig. So my final answer needs to be t equals 8 seconds. All right. Now, if I use this later in calculations, I'll go ahead and use that, which I am, because remember this is going to go in for time there, which is now going to allow me to solve for Bdubs velocity. So 1 equals 330 plus VB times 8.19 minus 3. So again, we'll go 1 minus 330. We will divide by that 8.19 minus 3, and it was 8.194. So that'll be divided by 5.194. And we get that VB equals, I know you guys like the decimal, so negative 63.3 meters per second. Again, though, 1 sig fig, because I used that 1 there. So my final answer needs to be negative 60 meters per second, just like that. Okay, so we just found the velocity of Bdubs. Nice job, y'all. That was challenging. Okay, that was a little bit difficult. It was very similar to some of them. You may say, well, that seems easier than some of the other ones. Well, yeah, but you've done it now, right? You've seen a question kind of like this, with the exception of the time thing, which was a difficult challenge for a lot of people, was to recognize that I needed to do t minus 3. Are there other ways to do this? Yeah, absolutely. There were a lot of people that said, well, I'm going to start at 0 and I'm going to go down to negative 329. That's fine, right? Anytime you use the x, really, you're going to end up finding the change when you move the x naught over. It's the change in x. It's the change in position that's important. Change in position, right? So there's a lot of different ways to do this. I just chose to do the way that seemed most straightforward with the numbers that I had. You'll come up with other ways to figure these out. You'll come up with other little shortcuts and things. But for now, this is the most straightforward way of doing it. Now, part A, yeah, was a little bit challenging adding in that t there. But now we actually are going to do part B, which is a little more challenging. Remember with the car and the truck in the previous question, that in order for the car and the truck to get to the same place at the same time, the car actually had to be going faster than the ball. That doesn't, or faster than the truck in order to catch up. That doesn't work very well here because the ball continues to accelerate while Bdubs goes the same speed. So in order to actually catch the ball at this point, what ends up happening is that the ball's falling, the ball gets to this point, Bdubs takes off, and he's actually going faster than the ball. So there's some point at which Bdubs passes the ball. He continues going, but he continues going at the same speed, but the ball continues to speed up, so the ball eventually catches back up to Bdubs, so that by the time we get to this 1 meter, the ball's actually catching up to Bdubs, which means the ball is faster than Bdubs at that point. So it's really weird. In order to be able to accomplish this problem, the way that it's set up, with Bdubs going at a constant speed and the ball accelerating, Bdubs actually has to pass the ball at some other point in time. And that's what the question for B is. In order for this to actually occur with Bdubs at a constant speed, now in a lot of the movies, the superhero will speed up. They'll be going down and they'll go faster and faster and faster to catch it right in time, right? But in order for this specific situation to work the way that it's set up, he needs to pass the ball so the ball eventually catches back up to him. So the question then is, at what time will he first pass the ball? All right, so this is a different point in time. This is a different information here. So we're going to go ahead and create a new table here with x naught, x, v naught, v, a, and t. Okay, we're going to have the ball. We're going to have Bdubs. They're still going to start at 330 meters, right? We do not know where that's going to happen. So we're going to leave that blank because the question says at what time will he first pass the ball. So I actually want to make sure that I have time here. So remember, time is for the ball. T minus 3 will be for Bdubs. This will not be the same T that we calculated up here in part A. It should be a different time. It should be earlier. And we may find that as we solve this, that we end up getting the same time as up here, but possibly 2 answers. That's obviously we're hoping for, that we can find when they meet up. Okay. So V naught for the ball is 0. We don't know the final velocity, so I'm going to hopefully avoid that. Now Bdubs goes at the same speed, so I'm going to go ahead and put V naught would be negative 63.3, and also V is negative 63.3. All right, just like that. I've got that the acceleration of the ball is negative 9.8, and I've got that the acceleration of Bdubs is 0. Now, what you may notice is that I don't really have enough information for the ball here, right? I'm missing v and I'm missing x. Anytime I'm missing and I'm missing t, right? 3 variables is way too many to be able to solve. So let's look at Bdubs. Bdubs, we've got the position, we've got the speeds, we're looking for the time. We're going to end up having the same problem that we had before with the acceleration. Remember, when the acceleration was 0, this equation is pointless and this equation is pointless because it gives us stuff that we already know. So we're left with this one right here, but I don't have x. So the only equation I could possibly use is this one. The other two, there's nothing we can do there. This one, I need x in order for this to work. So guess what? I've got 2 variables. I've got variable x, which is saying that they're going to be at the same position. So I'm going to put the same x for both of these to show that it's going to be in the same position. And then I'm going to try to solve for t here. All right. So now, how do we deal with 2 variables and how do we deal with 2 variables? That's really the question. Well, hopefully you recognize them and need 2 equations. Now, we already talked about how this is not helpful for Bdubs, but the top one is. The top one for Bdubs, we can go x equals x naught, which is that 330, plus v naught, which is negative 63.3, times t. And then the 1/2 at squared, but we know acceleration is 0, so that goes away. And then for the ball, we can write another equation. We need both x and t. The only equation that has both x and t would again be this top one here. So we'll go x for the ball is equal to x naught, which again was 330, plus v naught, which is 0, times t. Sorry, this t, I made a mistake already. This should be t minus 3 for Bdubs. I hope you caught me on that. I probably could feel you thinking, saying, but Mr. Bauer, you made a mistake. Yep, it happens. I told you guys, I don't know what's going on half the time. The fact that I can get through any of these questions at all is a minor miracle. Plus 1/2 times the acceleration, negative 9.8, times t squared. Now, if you're good with your calculator, you can actually just put this into your calculator. Your calculator will solve it for you. Now, if you have a fancy calculator like me, your calculator won't solve it for you. You're going to have to do a little bit of work. What I do recognize is that these are both equal to x. So I'm going to take this and I'm going to substitute it over here for x. Oh, I love this calculator. 189.9. And I know you're thinking, well, why do you use it then, Mr. Bywater? Well, because I like complaining about my calculator. Ta-da! So I did just go ahead and do the math for you. Hopefully you know how to do this on your calculator. If not, go ask me or go ask your teacher. I went ahead and did the algebra here. I solved for x. I got 2 answers, obviously. One of them was at about 8 seconds, which is the answer we found in the first question for our time. We are looking for the other one, which is 4.74 seconds. So just over halfway down is likely, after halfway of the time, I guess, is where we would have ended up meeting the ball the first time. All right, so there you go. We were able to solve the problem. Notice that algebraically, this one is significantly more difficult than some of the others. But again, all of these questions can be answered using just those 3 simple equations that we learned.